Could you imagine that amid fierce storms and freezing winds, the Vikings built houses that stood for centuries without using a single nail or drop of cement? At a time when Roman aqueducts were already collapsing and European castles were just beginning to raise their walls, Scandinavian craftsmen created architecture that defied nature itself. Their secret lay not in mystical powers, but in a deep understanding of wood and unique, invisible joining techniques. This is a story of how the genius of a carpenter surpassed the strength of metal, creating a shelter capable of withstanding the wrath of Odin himself. Watch the video to the end to learn how the ancient Vikings made woodwork as a single monolithic organism, and why their homes were stronger than most modern wooden structures. What if I told you that everything you believed was wrong? For the Vikings, wood was not just a building material, but a living ally that demanded respect and understanding of its nature. In their harsh world, where a storm could destroy a house overnight, every beam had to work, not just stand. They did not try to fight the natural movement and expansion of wood, as we do, using rigid fastenings. On the contrary, they used this movement to their advantage. The central idea was to allow the structure to breathe and move slightly under the pressure of wind and temperature fluctuations. If a house could shift slightly without collapsing, it was able to survive any hurricane, which was the main task in Northern Europe. That is why fastening with nails, which would make the structure too rigid, was unacceptable to them. Nails would weaken the wood at the fastening points, creating stress points that would inevitably lead to cracks and destruction under constant stress. Instead, Viking architecture relied on the principles of tight but flexible joints. Each detail had to be so precisely fitted that it did not require additional fasteners, but at the same time had a small gap to compensate for moisture and temperature. It was akin to the work of a watchmaker, where each element of the mechanism performs its role without coercion. Viking wooden houses, especially the so-called longhouses, were designed so that their own weight and the weight of the roof provided most of their stability. The heavier the roof, the more firmly the structure was pressed against the foundation, becoming literally pressed into the ground, which was ideal in high wind conditions. The layer of turf or stones on the roof was not only insulation, but also critically important ballast. This ancient philosophy was, don't nail, connect. It is not nails that hold a house together, but the house itself, thanks to thousands of perfect joints. This approach required more labor and time at the initial stage, but it guaranteed reliability for generations. This was the great wisdom of the Vikings, which we, modern people, often overlook, relying on machines and chemistry. We are very interested to hear your point of view. What do you think about how such simple things affected the durability of the building? Write about it in the comments, and don't forget to subscribe to our channel so you don't miss the next episodes. Want to know the main secret of Viking construction? The key element that replaced nails and cement for the Vikings was the tongue and groove joint, perfected to absolute perfection. This method, known in other cultures, acquired a particular brutality and precision in Scandinavia, necessary to withstand the local elements. It was not just a simple joining of two parts, but the creation of a complex three-dimensional structure where each beam locked into another, turning the house into a giant puzzle. The essence of the method is that a protruding element, a spike or finger, is cut at the end of one beam or log. A corresponding recess, a groove or socket, is cut into the second, receiving piece. These two parts had to be fitted together with jeweler's precision in order to join with a force that often required hammer blows. The main difference between the Viking mortise and tenon joint and other systems was its versatility and frequent use of hidden or semi-hidden joints. This meant that the mortises were often not made to the full width of the log, which preserved the strength of the main piece. Thus, the joint was as strong as possible, but almost invisible, preserving the aesthetics and structural integrity of the wood. To increase resistance to shear and pull-out, the tenon often had a wedge or dovetail shape. This allowed it to expand inside the groove when the wood shrunk slightly, creating additional friction and locking the joint. It was a living lock that only became stronger over time. Viking craftsmen did not use measuring instruments as we understand them. Markings were made using a rope, a compass, and a simple square, and accuracy was achieved through years of practice and a feel for the material. They knew how wood would behave during processing and exactly how to cut the fibers to avoid chipping. The use of mortise and tenon joints was widespread, from fastening vertical posts to horizontal strapping beams to connecting rafters and floor elements. It allowed the Vikings to build multi-story and long structures with a high degree of seismic stability, which is important for a region with active geological processes. As a result, a Viking house was not just a building, but a single organism in which each part supported the other. But knowledge of the terrain was only half the battle. Ready to learn how the Vikings turned ordinary land into part of their architecture? You've definitely never heard of this unique secret. The Vikings lived in an era when building foundations as we understand them today was impossible, as cement was unknown. However, their houses stood for hundreds of years precisely because the foundation was perfectly adapted to the harsh northern conditions. Their method was not about creating a rigid, impermeable base, but about creating a flexible, draining, and breathable cushion. Instead of pouring concrete, the Vikings used the principle of dry stone masonry and a gravel cushion. First of all, the top, fertile layer of soil was removed from the site to prevent the wood from coming into contact with decaying organic matter and to ensure a solid foundation. This process was called bed preparation and was extremely important. Then trenches were dug around the perimeter of the future house and under the load-bearing walls, which were filled with large stones, rubble, and gravel. This gravel cushion served three key functions necessary for the durability of the structure. First, it provided excellent drainage. All rainwater and meltwater flowing from the roof and ground did not accumulate at the base of the walls, but quickly seeped through the stones into the lower layers of soil. This was critical to prevent the lower crowns of the log house from rotting. Second, it served as a cushioning layer. Northern winters are accompanied by cycles of freezing and thawing of the soil. When the ground freezes, it expands, a phenomenon called frost heave. A rigid foundation would crack, but the gravel cushion allowed the entire structure to move slightly with the soil without being damaged. Finally, the most massive and durable stones, support stones or windowsill stones, were laid on this gravel cushion. These were carefully selected flat boulders that were placed strictly at the points of maximum load, at the corners of the house and under the vertical posts. These stones served as the foundation for the first wooden log, the binding crown. The binding crown, which was the most important part of the wall, was laid directly on the stones, never touching the ground. This ensured that the wood was constantly ventilated and did not retain moisture. As a result, even the lowest logs lasted much longer than they otherwise would have. This living foundation was an ingenious solution that demonstrated the Vikings' deep understanding of the local geology and climate. They did not try to fix the house in place, but created a system that was in harmony with the constant movement and humidity of the northern land. This method was simple, cheap, environmentally friendly, and, most importantly, incredibly reliable. Like this video if you think ancient building techniques deserve respect. What you are about to learn will change your perception of Scandinavian houses. Contrary to popular belief, most Viking houses, especially after the early period, were not solid log cabins. They actively used frame technology, which found its development in European half-timbering. But in the Scandinavian version, it was adapted to withstand the strongest winds. This system is known as a post and beam frame, or timber frame. First, a strong load-bearing frame was installed. It consisted of massive vertical posts that were rigidly connected to horizontal tie beams and rafters using a tongue and groove system and dowels. These posts and beams formed a rigid frame that carried the entire load of the roof in its own weight. The main feature was that the vertical posts were often dug into the ground or set on stone supports and then pressed down with the stones on the sides. This provided additional stability against horizontal shifts and overturning, which is critical in stormy winds. The deeper the post was set, the less the house was affected by the wind. The space between the elements of the supporting frame, the panels, was filled with less durable and cheaper materials. The most common method was known as wattle and daub, which involved weaving a framework of sticks and reeds and then covering it with clay or mud. This was not only economical but also effective for insulation. The wattle was made by weaving thin branches and twigs together and attaching them to a frame. This lattice work was then coated with a thick layer of a mixture of clay, straw, moss, and even manure, which provided excellent insulation and wind protection. As it dried, this mixture turned into a lightweight but durable composite material. The result was not a monolithic wall, but a composite structure, a rigid, load-bearing frame, and flexible, lightweight infill. Such a wall could withstand severe deformation without collapsing and was able to withstand enormous wind loads while remaining warm and dry. What do you think would happen if this technology were used in construction today? One of the most elegant and inconspicuous solutions in the Vikings' arsenal was the widespread use of pegs and wedges as the main fasteners. These wooden nails were not simply a replacement for metal ones, but a structural element that worked in perfect synergy with the rest of the wooden structure. They were as important as tongue-and-groove joints, completing the craftsman's work. Dowel pins were cylindrical or slightly conical rods made of very hard woods, such as ash or oak, which had high shear strength. They were driven into pre-drilled holes through both beams or logs being joined. The secret to the effectiveness of the dowel was that its diameter was slightly larger than the diameter of the hole. As a result, when driven in, it tightly compressed the wood fibers around it, creating enormous friction. This friction held the two parts together, preventing them from shifting under load. Moreover, dowels were often made of raw wood and driven into beams that had already dried out. Over time, the dowel dried out and shrunk slightly, but moisture from the surrounding log caused it to swell. This constant cycle of wetting and drying, expansion and contraction made the joint virtually eternal, keeping it constantly under tension. Wedges were used to reinforce existing tongue-and-groove joints. They were thin, conical bars that were driven into a slot made at the end of the tongue. When driven in, the wedge expanded the tongue inside the groove, locking it tightly in place. The hole for the dowel was often drilled with a slight offset, which was called eccentricity. That is, the hole in the upper beam was not drilled exactly above the hole in the lower beam, but with an offset of several millimeters. In this way, dowels and wedges did not simply connect, they activated the wood. They allowed the structure to be both rigid at key points and flexible as a whole, which was ideal for surviving stormy conditions. These simple wooden elements were evidence of the Vikings' high level of craftsmanship and their knowledge of physics and the properties of materials. What could be simpler than a roof? The roof of a Viking house was not just a shelter from rain and snow, but also the most important structural element that ensured the stability of the entire structure against the wind. In conditions where horizontal loads were at their maximum, the roof had to act as ballast in a giant strut pulling the walls together. Most Viking houses, especially in rural areas, had turf, peat roofs. This structure consisted of several layers, each of which performed a critical function, providing warmth, waterproofing, and strength. It was one of the most effective and environmentally friendly solutions of the time. First, a lath of thin boards was laid on the rafters. A layer of birch bark was laid on this wooden decking. The bark, stripped from trees in large pieces, served as the main waterproofing barrier. Birch bark does not rot and does not allow water to pass through, which made it an ideal natural material. A layer of dense turf or peat taken from the field was laid on top of the bark. The thickness of this layer could reach 20-30 centimeters. The turf itself, interwoven with plant roots, was incredibly heavy. The weight of the roof could reach several tons. It was this weight that was the key to storm resistance. The heavy turf roof literally pressed the entire frame structure of the house to the ground. This minimized the risk of the walls tipping over or shifting during the strongest gusts of wind, turning the house into a monolith rooted in the soil. The rafter system was also designed with these loads in mind. The rafters were connected to the load-bearing walls not with rigid fasteners, but with a system of tongue and groove joints, which allowed the roof to settle slightly under its own weight. This settling movement, in turn, further compacted all the frame joints. Over time, grass, flowers, and even small shrubs grew on the roof. This vegetation protected the turf from erosion and made the roof self-repairing. The house literally became part of the surrounding landscape, blending in with nature. In the next chapter, you will learn how the Vikings made their houses watertight without using sealants. What do you think they used instead of modern ceiling compounds? Sealing and insulation were just as important as structural strength, as the Vikings lived in harsh winter conditions. Without modern sealants and insulating foams, they turned to the most accessible and effective material that northern nature had to offer: moss. This material, which we today see simply as a plant, was a valuable building resource for them. To insulate walls, especially in log cabins, they used what is known as interlog moss. This was a special type of moss, most often sphagnum moss, which was collected, dried, and then laid in a thick layer between each log in the cabin. The moss acted as a modern sealant. The secret of moss lay in its amazing properties. First, it had excellent thermal insulation qualities due to its porous structure. Second, it was a natural antiseptic containing substances that prevented rotting and mold growth. Moss protected the wood. Most importantly, moss was hygroscopic, meaning it could absorb and release moisture. When the logs dried out, the moss swelled and filled the gaps that formed. When the wood swelled from moisture, the moss contracted. This ensured that the joints remained sealed, which no rigid material could achieve. In addition to moss, the Vikings used tree resin as an additional waterproofing agent. The resin, extracted from pine and spruce by heating the wood, was thick, sticky, and waterproof. It was applied to the most vulnerable areas: log joints, lower log walls, and roofs to seal the joints between the boards. The resin was especially important for protecting the ends of the beams that protruded outside. These parts were most susceptible to rot, as the wood actively absorbed moisture through them. Impregnation with resin created a dense black crust on the surface of the wood, which completely prevented water from penetrating. Thus, Viking houses were not only durable, but also remarkably warm. Thanks to these natural materials, they achieved what we now call energy efficiency without plastic windows or mineral wool. Nature provided them with everything they needed to survive. The Vikings' supreme craftsmanship would have been impossible without the exceptional quality of their tools. Unlike modern builders, who use saws, cutters, and power tools, Viking carpenters relied on just a few basic tools, the most important of which was the axe. It was not just a cutting tool, but a multifunctional, high-precision tool, perfected to perfection. Viking axes were divided into several types, each with its own narrow specialization. The most important was the adze, an axe with a blade perpendicular to the handle, which was used for trimming and leveling horizontal surfaces. The adze allowed the top edge of a log to be quickly and accurately leveled for the tight fitting of the next log. A heavy axe with a long handle was used for cutting and rough work. But for finishing and precision work, a carpenter's axe was used, a tool with a wide, thin, and very sharp blade. It allowed the wood to be cut into the finest shavings, creating a perfectly smooth and even surface. Special chisels were used to cut grooves and sockets. They were massive, had a strong blade, and were designed to withstand strong blows from a wooden hammer. Chisels allowed the internal corners of tongue and groove joints to be formed with jeweler's precision. It is important to note that all these tools were incredibly sharp. The high-quality steel that the Vikings knew how to smelt and temper allowed them to sharpen the blade to razor sharpness. Sharpness was not just a whim, but a necessity. A sharp tool does not tear the wood fibers, but cuts them, creating a smooth surface that is better protected from moisture and decay. All measurements and markings were made using simple but accurate tools. These were knotted ropes, measuring sticks, and compasses and set squares made of wood. The Vikings worked with geometry, relying on ratios and angles rather than absolute numbers. The skill of a carpenter was valued in Viking society no less than that of a warrior or shipbuilder. A man capable of building a sturdy house ensured the survival of his entire clan. His tools were his pride and the extension of his hands, and each joint was a signature of his craftsmanship. The architectural apotheosis of Viking house building was the longhouse, langhus, a monumental structure that was simultaneously a dwelling, a craft workshop, and a community center. The longhouse was not just a building, but a reflection of the social structure and way of life of the Vikings. Its size and layout were designed to maximize survival in the harsh climate. These houses could reach 30-40 meters in length and accommodate up to 100 people with their livestock and belongings. Structurally, the longhouse was an elongated rectangular frame where the central space was the most important. The central space, or main hall, had a high ceiling, often reaching the ridge of the roof. In the center of this hall was a long hearth, langeldor, which served as the only source of heat, light, and a place for cooking. Smoke from the hearth rose upward and escaped through an opening in the roof or through special slits. On either side of the central hearth were rows of wooden posts that divided the space into 3 naves, like in an ancient church. The side naves served as bedrooms and storage areas. The floor in the side naves was raised and covered with skins and straw to keep it warm and dry. The posts supporting the roof were the most massive elements. They were dug into the ground or set on stone supports and connected to the roof beams with the strongest possible joints. It was these posts that bore the enormous weight of the turf roof, forming the backbone of the entire house. The walls of the house were often slightly curved inward, which gave the structure additional stability against lateral wind loads, like a ship. This shape also contributed to better water drainage from the roof and protection of the lower crowns. The shape was not only aesthetic, but also an engineering solution. The longhouse was designed as a single, multifunctional complex. People, livestock, and supplies were housed under one roof, which was essential for conserving heat and ensuring safety. The heat from the animals' bodies in the hearth helped maintain the temperature, allowing people to survive. Thus, the Viking longhouse was not just a sum of technologies. It was an engineering response to the challenges of climate and social needs. It demonstrated that Viking architecture was organic, deeply thought out, and absolutely reliable. As we conclude our dive into the world of Viking house building, we see that their methods were not just primitive, but were the pinnacle of engineering wisdom based on an understanding of natural materials. The Vikings developed a system that was strong, energy efficient, and durable, using only an axe, a chisel, and the gifts of nature. Their legacy lives on today, continuing to inspire modern craftsmen. The main lesson that the Vikings teach us is that the strength of a structure lies not in rigidity, but in flexibility and precision. Their houses survived storms because they could move slightly and adapt to changing loads, like a tree branch. Nails and cement create a brittle rigidity that breaks down under extreme deformation. Tongue and groove technology and the use of wooden dowels have returned to modern architecture in the form of frame house construction and long-span wooden structures. Engineers around the world have realized that properly joined wood often surpasses concrete and steel in reliability, especially in seismic conditions. The turf roof we discussed is now experiencing a renaissance in the form of green roofs. Modern environmental trends are bringing us back to the idea of vegetation cover on roofs, which provides the same thermal insulation, sound insulation, and water drainage as in ancient times. The Vikings did not have drawings or calculations, but they had a deep intuitive knowledge of how to work with wood so that it would last a long time. This knowledge was passed down from generation to generation, becoming part of culture and art. Each joint was an act of respect for the material. Ultimately, Viking houses stood for hundreds of years, not because of magic, but because of craftsmanship and respect for the laws of nature. They built to live, and their architecture is a hymn to human survival and ingenuity. This legacy teaches us that the most reliable material is the one we understand and work with in unison. We conclude our exploration of the ancient secrets of Viking house building. We have seen how, with an axe, a chisel, and a deep understanding of wood, they created architecture that was stronger than many modern structures. From flexible tongue-and-groove joints to multi-ton turf roofs, each solution was an ingenious response to the challenges of the harsh northern world. They proved that in the hands of a master craftsman, wood can be more reliable than metal, and nature can be the best architect. Which of the Vikings' engineering solutions do you think is the most ingenious? The use of moss as a sealant, heavy turf roofs, or the wooden peg system? Share your opinion in the comments, and don't forget to subscribe to our channel so you don't miss out on new research into ancient technologies that change the world.